Welcome students. Here we will be discussing a very interesting question from the chapter Mathematical Induction. Here question is, prove by the principle of mathematical induction for all n belonging to the set of natural number, capital N. The statement is 1 plus x to the power n is greater than or equal to 1 plus nx, where x is greater than minus 1. So we have to establish it, we have to prove it. This sign is known as inequality sign. Okay, so here greater than equal to, it doesn't mean that this left hand side will be greater as well as equal, cannot be greater and equal both. Here it means that LHS is whether greater than RHS or equal to RHS, either or. Okay, so let us see the solution here. Here given mathematical statement is this one, and mathematical statement is denoted by this notation Pn. So here Pn is 1 plus x whole to the power n is greater than or equal to 1 plus nx, where x is greater than minus 1. Let us call it relation number 1. And we are going to establish it, we are going to prove it through principle of mathematical induction. And we have to take 3 steps for principle of mathematical induction. First step, we have to show that P1 is true. How we will get P1? By putting n is equal to 1, we will get P1. So we have to first of all prove that P1 is true. Second step, we have to assume that PR is true. When we will put n is equal to some natural number r, we will get this statement. When n will be replaced by r, we will be assuming it that PR is true. And third step, we have to show that PR plus 1 is true. So let us start it. So first step, we have to show that P1 is true. Show that P1 is true. And you know how we will get P1? By putting n is equal to 1 here. So putting n is equal to 1 in relation number 1, we will get P1. And P1 will be here 1 plus x whole to the power 1. Not necessary to write it. 1 plus x is greater than or equal to 1 plus 1 into x. Putting n is equal to 1 here, or we are getting 1 plus x, this is greater than or equal to 1 plus x. So as I have told you that this inequality relation will hold either greater or equal, correct? So here equality sign is existing here. 1 plus x is here in both the sides, LHS as well as RHS. So this equality sign holds good, which is true. We will write here which is true. Why? Because 1 plus x is equal to 1 plus x. Okay. So therefore P1 is true. P1 is true. First step is complete. Second step, we have to assume that PR is true. Assuming that PR is true. And as you know, how we will get PR? By putting n is equal to r in relation number 1. So now putting n is equal to r in relation number 1. So we will get here PR will be 1 plus x whole to the power r is either greater or equal to 1 plus r into x. We are assuming it that this is true. Let us write it relation number 2. And third and last step, here we have to show that PR plus 1 is true. And how we will get PR plus 1? by putting n is equal to r plus 1 in relation 1. So, putting n is equal to r plus 1 in relation number 1. Okay. So, we will get here p r plus 1, putting n is equal to r plus 1 will be 1 plus x whole to the power r plus 1. This is greater than or equal to 1 plus r plus 1 into x. We have to establish it, correct? So, you see here 1 plus x whole to the power r plus 1. This can be written as 1 plus x whole to the power r into 1 plus x, correct? Here we will use this relation number 2 for proving, for showing it, for proving it, okay? We will use relation number 2, correct? And what is relation number 2? 1 plus xr is greater than or equal to this much. Means LHS is greater than or equal to RHS. Means RHS is smaller than this much. So, if we replace 1 plus xr by this expression is smaller. So, it will become smaller or equal to 1 plus Rx into another factor is 1 plus x, okay? And this is equal to 1 plus Rx into 1. So, this is 1 plus Rx into 1 and 1 plus Rx into x. So, we are getting here 1 plus Rx plus multiplying with x. So, this is x plus Rx square, and here x square is always positive number because x is greater than minus 1 and square is here. So, definitely Rx square is a positive number. So, if you replace this much, if you delete this much, so definitely here this is greater than or equal to 1 plus Rx, correct? So, you can write that this is greater than or equal to 1 plus Rx. Why? Because rest of the part is positive number. Of course, x may be negative, but x square is positive, and this x square positive number is being multiplied with some natural number. So, in spite of being x negative or maybe 0 also, this part is always positive. So, if you omit this part, then remaining part will be greater and the resulting part will be smaller. That is why we are writing this notation here. This is smaller than or equal to this much, correct? Follow it? Okay, fine. So, therefore, we are proving here that 1 plus x whole to the power r plus 1 is greater than equal to 1 plus, we have to prove 1 plus r plus 1 into x. So, please make a correction here. Here we have to show 1 plus r plus 1. So, this is, here we are getting 1, this is 1, and from these two terms we can take x common. So, this is plus 1 plus r from here and plus 1 from here, r plus 1 into x plus Rx square, which is a positive number. So, therefore, one plus, you write here r plus 1 into x. You see 1 is here, 1 plus r plus 1 into x, and this is positive number, x square is there, so of course this is positive. So that's why this much part is smaller. So we are writing here that this is smaller than or equal to this much. Okay. So we are proving here at this step. So therefore we can write, therefore P r plus 1 is true. You see, we had to prove it here. This is P r plus 1, which you are solving here. 1 plus x to the power r plus 1 is greater than or equal to 1 plus r plus 1 into x. Therefore P r plus 1 is true. So all steps are complete here. Just we have to write one line statement here, that therefore by the principle of mathematical induction, by the principle of mathematical induction, Pn is true for all n. So we got the result. It has been proved here. Hope you have understood it very well. This is very interesting question, and we will see some more problems, important question, interesting questions in other videos to come. Thank you very much for watching this video. Wish you all the best.